This is the fourth section of the roots of polynomials, and this section is all about lots of different expressions which relate to the roots of polynomials. Now what you're going to see here is lots of different things that if you can remember some of them, it just saves time. So for example, it's just telling us that if we work this out here, 1 over alpha plus 1 over beta, in fact 1 over anything plus 1 over anything else, this is what it becomes. The same if we're adding 3 of those together, this is what it becomes, and so on. Okay, so these are what we call the rules for reciprocals. Yeah, and you know, if you needed to work something out where you needed to add those quickly, then here's a rule that can help you do it. So for example, if I was adding I don't know, a half plus a third, now, this may not be the way that we do it, so a half plus a third, so alpha's 2, beta's 3, you could do 2 plus 3 over 2 times 3. Yeah, so there's lots of different tricks we can use here. So these are the first box in yellow. These are the rules for reciprocals, can be used if you memorize them without proof. In a moment we're going to go through why these are useful. Then we've got the rules for squares. So something squared plus something squared, you can see how it can be sort of factorized. So here's it's sort of almost like completing the square here. The same thing when we're adding 3 lots of squares together, you can see what it factorizes to give you. And the same if you've got 4 different lots of squares added together. Yeah, and again, if we memorize these, it means that we can get straight from this side to this side without actually having to prove anything. So these are the rules for the sums of squares. Then we've got these rules for the sums of cubes. So alpha cubed plus beta cubed can be factorized like this. Yeah, again, if you memorize it, this can be used without having to prove this or even trying to factorize it yourself. You can just quote that without any further explanation. And then if we've got 3 different things cubed and added together, again, this is what it becomes. So we've got the rules for reciprocals, the rules for the sums of squares here, and the rules for the sums of cubes. And then we've got this last box here in purple, the rules for the powers, product of powers. So if you've got something to a power times a different number to the same power, this is what it can be factorized to give you. And the same when you've got 3 things in your product and 4 things in your product. Okay, now why might these be useful? Well, it's probably about some of the things that we may recognize that we may see somewhere else. So for example, this a plus b turns up in the roots of a quadratic equation. A plus b for a quadratic, not the roots of a quadratic equation, that was the minus b over a part. Yeah, the bit at the bottom here, the a time or the alpha times by beta. Did I say a times by b before? I meant alpha times beta, or alpha plus beta. That's the c over a that you find in in the roots for a quadratic. Okay, anything else? Well, I see the alpha plus beta here as well, and 2 times alpha times by beta. Okay, so there's my negative b over a and c over a again, and looky up here, there we go. Yes, I'll try and color code this. Anywhere else that we see that? Alpha plus beta down here in orange. Yeah, so can you see they turn up all over the place? Every time I see alpha plus beta, that is negative b over a for the quadratics. Okay, how about the cubics? Now I see alpha plus beta plus gamma. Now alpha plus beta plus gamma for the cubic is negative b over a. So this negative b over a here is now for the cubics. Is there anywhere else I see alpha plus beta plus gamma? I see it here. There we go. So that's also negative b over a. and I think that's it for the cubics in terms of alpha plus beta plus gamma. Now the other one, I hope I don't run out of colours here, so let's go for yellow. So this one here that I see for the cubic, that's C over A. Okay, so this is C over A for the cubics. Now where else do I see that? So the sum of alpha beta basically. See it there. And I see it here as well. Okay, so can you see like it's all these rules for the roots of these quadratics, cubics and quartics that turn up. And I suppose the last one, run out of colours here, let's go for red, it's going to be a bit dark. Alpha times beta times gamma is negative d over a. So this is negative d over a for the cubics. That's meant to be an a at the bottom. Negative d over a. So where else do I see alpha beta gamma multiplied like that? Here it is. I see it here, alpha beta gamma, and here as well. Okay, so that's everything for the cubics done. Oh, I missed one out. Alpha plus beta plus gamma. And I also missed out alpha beta. So that's there as well. So the only thing left is the quartics. Now with the quartics, I don't really want to be highlighting in white or black. That won't really help. Let's see what purple looks like. Not great. Maybe what I'll do, I'll just draw a circle around it. So let's just draw around it in this color. There we go. So there, do I see that anywhere else? No, but that for our quartic is negative b over a. So negative b over a, not particularly clear, but that's negative b over there, a there. And then different color. Let's go for purple around this one. So all of that bit there, that is the sum of alpha beta, which is c over a. So you can see all these patterns turning up. And then the last one we haven't used is the product of the roots, which is going to be this one up here, and that is e over a. So this is why it's useful to know all of these rules, because you can see where they turn up. Yeah, and we've used every single one. I've tried to color code them, but this is how we can link rules to these reciprocals, the sums of squares, sum of cubes, and the products of the powers. Right, okay, so part A is just going to be expanding the brackets. So alpha plus beta plus gamma times itself plus gamma. So, you know, if I was going to draw lines in, I'm basically going to be multiplying all of those and then do the same with the beta and then the gamma. So I'm not going to draw arrows, there's just going to be too many of them. You could also, if you want to, put this in a grid and multiply it that way if you want to, if you find it more helpful. So you could just do like a 3x3 grid like this. Obviously draw neater than mine. Put your alpha, beta, gamma here, at the side alpha, beta, gamma here, and just multiply everything and just put the results in the boxes, like alpha squared, alpha beta, alpha gamma. You might find this a bit easier actually. Alpha beta, beta squared, beta gamma. alpha, gamma, beta, gamma, gamma squared. Yeah, that might be a nicer one to do. Then we can see that these go together. Well, we've got those two are going to go together, and these two are going to go together. So that might actually be a little bit easier in terms of multiplying out. So that's going to give us, let's write all the squareds out first. So alpha squared plus beta squared plus gamma squared, and then we've got 2 lots of alpha beta plus 2 lots of alpha gamma, so 2 lots of alpha gamma plus 2 lots of beta gamma. Okay, part B says the cubic equation has roots alpha beta gamma, surprise surprise, such that, okay, the sum of alpha beta, remember you can write this like this, is 7, and alpha plus beta plus gamma, which you could just write as the sum of alpha, equals -3. Find the value of alpha squared plus beta squared plus gamma squared. Now, why have we just done what we've done in part A? Well, let's write out what we've just done in part A. We've worked out that alpha plus beta plus gamma all squared is alpha squared plus beta squared plus gamma squared plus 2 lots of alpha beta plus alpha gamma plus beta gamma. Now, if we rearrange that, it's actually in the green box as one of the rules, but basically if we were to rearrange what I've got there, then alpha squared plus beta squared plus gamma squared is equal to alpha plus beta plus gamma all squared. So I'm just rearranging what I've just done at the top, minus 2 times alpha beta plus alpha gamma plus beta gamma. So this is now just substituting in. Alpha plus beta plus gamma in the question is -3. So I've got -3 squared minus 2 times, well, the sum of alpha beta we're told is 7. So it basically becomes 2 times 7. So that's going to be 9 minus 14. So we get an answer of -5. Yeah. Right, this example here, the 3 roots of a cubic are alpha, beta, gamma. Given that alpha, beta, gamma equals 4, okay, so it's one bit of information, and the sum of alpha, beta basically is -5, and alpha plus beta plus gamma is 3, find the value of these, what you get if you basically added 3 to the roots and found the product of them. Now we're going to actually multiply out alpha plus 3, beta times plus 3, gamma times 3. Then we can compare it to the values that we've got, and you'll see that we should be able to substitution numbers in with maybe a little bit of multiplication or adding to get it to fit this. So I'm going to start with the first 2 and multiply those out. So that will give me alpha beta plus 3 alpha plus 3 beta plus 9. And now I'm going to multiply that out with the gamma plus 3. So I could write equals here. So that's what I'm doing. So if I multiply that out, I'll have alpha beta gamma plus 3 alpha beta plus 3 alpha gamma plus 9 alpha plus 3 beta gamma plus 9 beta 9 beta or beta plus 9 gamma plus 27. Now what we want to do here is to put some bits together. Now I can already see in the question that is 4. Okay, now let's put all of these together. That one, this one, all the terms that have got 2 bits to them. So we've got alpha, beta, gamma plus 3 lots of alpha, beta, alpha, gamma, beta, gamma. Okay, that's looking all right so far. Then what do I have? Well, I've got this 9 alpha, 9 beta, 9 gamma. So that can be factorized, and I can write plus 9 alpha plus beta plus gamma. And then on the end, I'll just have this plus 27. Right. So now the numbers can be substituted in. Alpha times beta times gamma. Let's just highlight this. So this is 4. So 4 can go there. 4 plus 3 times. Right, okay. So this bit here, we've been told in the question, is -5. So we have 3 times by -5. 3 times by -5. Okay. And we have 9 lots of, so again highlighting, got alpha, beta, gamma, and we're told that alpha, beta, gamma is 3. So now we can write 9 times by 3 plus 27. So that's going to be 4 minus 15 plus 27 plus another 27. So let's see what we get when we do this. 4 minus 15 plus 27 plus another 27 gives us an answer of 43. So this is basically a lot of algebra. It's multiplying things out and looking at the bits that we get, collecting the like terms once we've expanded, and then once we've expanded and factorized things together, then substituting the values in. So this is pretty much algebraic, all of this stuff. Right, you should now be able to do exercise 4D on pages 63 to 64. Okay, so a lot of this is see if you can memorize the rules for, now there was the rules for reciprocals. So if you can remember those, it saves you having to multiply things out. The rules for powers, okay, they were probably like the easier ones to remember, I think, out of all of them. Then we've got the rules for the sums of squares and the sum of cubes. So there wasn't anything for the sum of quartics. Okay. So yeah, if you can remember those rules, that will save you sort of having to multiply things out and work them out. But whenever we do questions like this, it's pretty much expanding brackets. Now when you expand your brackets, take care that you don't make mistakes, because you might be expanding things out where it's 3 sets of brackets or there are 3 or 4 things in the brackets. So I'm just going to put like exclamation mark and expand the brackets. Then after that, you'll probably do a bit of factorizing. Yeah, to get things in brackets. And the reason why you're factorizing is you want to compare things, don't you? And when you compare, you're looking for things like maybe, I don't know, alpha, beta, gamma, this type of thing, or maybe it might just be like alpha plus beta plus gamma, these types of things. So that's what you're looking for, so you can then substitute those things in.